Hello everyone, my name is Naimisha Churi and I'm here to talk about my applied machine learning project Image Restoration with CNNs. I have selected the paper Deep Image Prior written by Dmitry Ulyanov, Andrea Vidaldi, Viktor Limpitsky in the year 2018. The motivation for this project is that I want to restore the images from my parents' wedding albums and some old pictures of my grandparents. I want to surprise my parents with the restored images and learn more about CNN and neural networks in the process. I encountered this paper while researching for ways to perform image restoration with little to no dataset, and the idea that the structure of CNN is enough to solve the image restoration problem is fascinating. The paper presents the claim that CNN contains knowledge of the natural image. In addition, the authors utilize the claim for image restoration tasks like image denoising, super resolution, in painting, and more. I chose to play with the denoising part of the paper and experiment with it to restore my images, and actually ended up reducing their quality. Haha! But let's look into paper's fascinating concepts. Firstly, what is a CNN? A convolution neural network is a deep learning algorithm which can take in an input image, assign importance or learnable weights and biases to various aspects in the image, and be able to differentiate one from the other. The convolution layer is the core building block of CNN. It carries the main portion of the network's computational load. This layer performs a dot product between two matrices, where one matrix is the set of learnable parameters, otherwise known as a kernel. The other matrix is the restricted portion of the receptive field. The kernel is spatially smaller than an image but might be more in depth. This means that if the image is composed of RGB channels, the kernel height and width will be spatially smaller than the image, but the depth extends to all three channels. The approach in this paper utilizes the concept of priors, specifically the explicit priors, which refer to the belief that we have when there is a lack of information. The explicit prior is when we don't need any additional data other than our image for the process of restoration. The principle followed in this paper is that the optimization problem can be thought about as a task to produce the desired clean picture X with the goal of creating an image X star that is both similar to the noisy image X cap but also natural or clear like the cleared image X. Regularization was also employed in this project to avoid overfitting on the noisy image. Instead of optimizing over the image, this suggested technique employs parameterization and has a parameter space with a mapping of 4 from parameter space to the picture X. Instead of optimizing over the image, it optimizes over the thetas. Here are some of the images that I wanted to restore, but as you can see, it's not that good. I have to work on the quality, improvement of the quality and sharpening of the images. So for the results and future works, since my GPU subscription of the Colab ran out, I have to work on, and since there is a time constraint, I am also working on a way to implement this on my device instead of the Colab notebook. For the results and future work in this project, I'll be working on improving the results and the quality of the pictures from my dataset, implementing an extra CNN for image sharpening, and working on image in painting for images that have been damaged a lot. Thanks a lot. That's it for my presentation. Thank you for your time.